Hello, hello, hello. Can you hear me? Yes, perfect. Okay. Nice to see you all. I know it's early. I have a green tea from 7-Eleven. If you're jet lag or whatever, I recommend it. No sugar. I think it's nice. This should get me through the whole hour. We have 1 hour to talk about Damn Vulnerable DeFi. Thank you, Muli, thank you, Phil, and thank you for all the organization for the honor of opening this new DSS 101. Super excited to be here. So yeah, we have 1 hour to just go through Damn Vulnerable DeFi. Of course, we won't go through everything of it, but we will be showing some cool features about it. At some point, that should be sharing screen, and you should be start seeing stuff there because I'm only seeing that there. And that's perfect. Thank you very much. So yeah, for those who don't know me, I'm Tincho. I'm a security researcher. I've been doing security stuff on Ethereum for the past 5 years or more. I don't know. I lost count. I work at the Red Guild, a small team from LATAM that I co-founded. And I will be telling you a little bit more about the Red Guild very soon. The idea is to just give you a very quick intro, and then I will just be opening terminals and VS Code and those kind of things that you nerd people like. So yeah, for today is Damn Vulnerable DeFi. If you want to follow along, to some extent you will be able to. But I have only 1 hour, and Damn Vulnerable DeFi is huge. And I want to show you many things and cool features that it has. So I don't know to what extent you will be able to follow along if you're only starting out in smart contract security. So perhaps you just can, I don't know, listen to me and see the things that we will be able to do in the vulnerable DeFi. And hopefully this will be a trigger for you to get excited about it, to understand that, in my humble opinion, not because I created it, but because some other people have told me so, that it's one of the best resources to get started in smart contract security in a practical way. So hopefully you will find it so as well. So if you want to, you can go to that page, vulnerabledefi.xyz. There's a repository that I will be showing you, and you only need to have Foundry installed, which is this development framework for smart contracts. So that should be it. In any case, I will be showing you later about it. So a little bit about the Red Guild, very quick. I know you are not here to listen to me much about what we do and why we do it, and those kind of things. But we do security and education for the public benefit of the Ethereum ecosystem, right? So we are a very small team from LATAM. We are supported by the Ethereum Foundation with grants of the Ethereum Foundation. We don't sell products, we don't sell services, we don't sell audits, we don't sell tooling, we don't have freemium, we don't have logins, like nothing, right? So we just work for the community, in service of the community. We try to complement the other security firms in the space that are kind of more selling commercial services and products. We just do this for the community for free, and everything we do is just for you. Everything is just contributing public goods to Ethereum security, right? I think we are only one of the few teams that are actually doing this. And the vulnerable DeFi is actually part of that, right? These days, we are kind of positioned in this way. I wouldn't say we're a Web3 team. I wouldn't say we're a Web2 team. We're kind of trying to understand that security goes well beyond what you call Web3 and sometimes gets into the realm of Web2. And even those differences are very difficult to pinpoint sometimes. So we are just providing security for Ethereum, right? Many of the initiatives that we have, it's about education. We have gamified learning platforms such as the vulnerable DeFi and some others I will be telling you about because we are also announcing some stuff at DevCon 2. We do security research and bug hunting. That means participating in contests, participating in bug huntings, doing spot checks. We do security awareness campaigns. We won't be doing this right now at DSS, but for instance, last year in Ethereum Argentina, we did an undercover security campaign in which we did some phishing and scams and everything just to raise awareness of security in the community. We do tooling. We participate as members of the Security Alliance scene. We do community engagement and many more things. If you want to read more about us, you have the website. And that's all for the introduction of the Red Guild. So for today, it's what is the vulnerable DeFi? We will do the quick local setup, and I will just be hacking challenges, right? There should be Okay, no, I won't go into that later. So why you should play Damn Vulnerable DeFi? Okay, so we have realistic up-to-date scenarios. That essentially means that in Damn Vulnerable DeFi you will find actual stuff that's happening on mainnet, okay? I think that these are one of the most up-to-date challenges that you will find. You will find security flows and code patterns and latest version of the libraries, and we are integrating with many external protocols. And you will find that, hopefully, if you play Damn Vulnerable DeFi, you will be quite prepared to then go into contests, for example, or start participating in backhunting, because you will have already seen many of the practices and bad coding patterns that we see every day on mainnet. So no bullshit, right? You just play, no logins, no freemium, no nothing. You download something to your machine and you run it, okay? You don't need anything to play in Damn Vulnerable DeFi. Only Foundry and you wanting to play, that's it. And these are many of the things. I don't know if you actually see all of that, but we have many stuff, right? So flash loan price, oracles, governance, NFTs, DEXs, lending pools, smart contract wallets, timeless, tokenized vaults, meta transactions, and more stuff. Many of the things that, again, you will find on real contracts on mainnet are already included in Damn Vulnerable DeFi for you. It's all very badly coded, very broken. We are very proud of that poorly written code, so please take a look at it, and hopefully you will, have fun with it and learn a lot. Yeah, okay, the workshop. Spoiler alert, so I will be solving challenges, okay? So that means that if you don't want to see the solutions, you should probably be leaving now. But don't worry, because I will be solving like the introductory ones, the ones that you will probably solve anyways. But just make sure that if you really don't want to see any of the solutions, I don't know, don't listen to me much. Other than that, I don't think there's much introduction. Yeah, I should go to the Damn Vulnerable DeFi. I will do the overview and the setup. I should also have mentioned, yeah, okay, so if you speak with many, known security researchers or popular security researchers on Twitter, they will probably tell you that Damn Vulnerable DeFi is one of the resources that they started their career with. So again, don't overlook Damn Vulnerable DeFi. I think it's very powerful. And I would suggest you also that if you start playing it, share something on Twitter, share your write-ups, share your solutions. In that way, you will also help us to spread the word of Damn Vulnerable DeFi. I think this is actually the first workshop we ever do of Damn Vulnerable DeFi, like live. And Damn Vulnerable DeFi is already 4 years old, I guess. And I don't know, it's very popular in the community, just word of mouth. So if you like it, just spread the word. Okay, so if just get started, right? So there's not much to tell. If you go to the website, it's just this, very simple, nothing too fancy. Some introductions, we will see all the challenges here. We'll just be playing two. We've probably trusted and side entrance. If we have more time, I could do kind of a quick walkthrough of some others, but I think that with two, we will already be quite covered. But we'll see what happens. They are not necessarily ordered by difficulty. Perhaps they are, I don't know, because probably the starting ones are to some extent easier, and then, anyway. This is version 4. So the last challenges that you see there are the newest ones. I don't know if there are already public write-ups about them, perhaps 1 or 2 that I have seen. So if you are like feeling adventurous, you can actually start playing the last ones too, and start publishing write-ups. That would be quite cool, because not many people are actually solving them or being able to solve them. So how to play, all instructions in the repository. So this is essentially it, right? So if I open Truster, for example, which is going to be the first level that we will tackle, you will usually find some context for the challenge, and then you can actually see the contracts, and we will see how that looks like. So we will be doing this, and we will be doing also this one, which is called side entrance. And then we will see if we have time to do more. Probably we won't. What else? Okay, So Truster is about two things mainly, flash loans and arbitrary calls. So we will be diving in a few minutes into what a flash loan is, what does it look like, and why having arbitrary calls from your contracts to any other contract on mainnet is not the right thing to do. And then we will have side entrance, which is about re-entrancy, but not the usual one that you will find on places. Some bad accounting of handling Ether, and also how do we mix that with flash loans, right? And I could go on, right? We have more levels and stuff, so if we have time, we can go over them. Or after this workshop, you can just, I don't know, come to me and we can solve something together or whatever you want. So yeah, the repository is here, github.com/theredguild/Damn Vulnerable DeFi. If you go to the website actually and you click this link, you will go straight to the repository. And then you can just, as whatever repository, just clone it to your machine, and that's it. If you have Foundry installed already, that's perfect. Otherwise, you can use a dev container if you're using Visual Studio Code, if you want to start local dependencies on your host machine, which is a nice practice. Tomorrow, we also have one workshop, and we will be talking about dev containers and why they matter, and why you shouldn't be installing dependencies on your host machine. So come listen to us too. So yes, I have already downloaded things and cloned the repository. So I have things here. So that's the repository that I downloaded. I already ran force build. So it's already compiling everything. If you haven't done so, please do it. Download the repository, clone it, and run force build. That will actually download all the dependencies to your machine. It's just downloading other GitHub repositories that we need to do this, such as many of these, right? I don't know to what extent you can see this, but those are the dependencies that we use, right? So we have contracts from Uniswap v3, Uniswap v2, Uniswap, Soulmate, Solidity, SafeSmart contracts, permits tools, Open Zeppelin contracts, multi-calls, and many, many more stuff. But today, it's going to be simpler than that. So we'll just open Visual Studio Code. I will trust the authors. If you come to our workshop tomorrow, you will find many surprises about this. So please come. I will open this in a dev container, so that means I will be hacking inside my dev container, which is nice, as I was telling you. So here we are. I will do, let me see if I can do this again here, force build. Nothing to compile, and you should, yeah, but if I do this, I don't see anything. Okay, hopefully you can see something. I need to check out the latest version, which is 4.1. So there we are. Just make sure we are there. Perfect. So yeah, that's it. Okay, challenges. Damn Vulnerable DeFi, it's about, each challenge is about a set of contracts and a test, okay? So if we want to play, for example, Truster, we go to the Truster folder, we have a README that has the context that you need for the challenge. And it says, in this case, more and more lending pools are offering flash loans. In this case, a new pool has launched that is offering flash loans of DBT tokens for free. I'm about to explain you what DBT tokens are. The pool holds 1 million DBT tokens, and you have nothing, you as the player, right? So to pass the challenge, you should rescue all funds in the pool, executing a single transaction. Deposit the funds into the designated recovery account. Okay, many things to take into account. One is that we have a DBT token. The DBT token is the Damn Valuable token that we use in Damn Vulnerable DeFi. It's just an ERC20 token. So if we go to it, the Damn Valuable token, which is right here, you will see that it's just usually ERC20 token, right? So nothing too fancy. Everything it's doing is just minting to the deployer of the token the maximum amount of tokens. This shouldn't be broken. The tokens in the vulnerable DeFi should actually be safe. If you broke this, probably you have bigger problems in the ecosystem. But yeah, this should be fine. Okay, so in our challenge, you as a player won't have anything, but we're about to see a contract that has 1 million of these tokens assigned, and we should be able to rescue them. And notice that I see rescue, and I don't say steal or whatever other word. Okay, Damn Vulnerable DeFi is particularly focused on rescuing funds from contracts, and that's a big difference and a very important mentality that you should have. What we are learning here is about rescuing funds and depositing them into, in this case, designated recovery accounts, following what, for example, Seal and their safe harbor are pushing these days. We are not keeping funds, we're always depositing them into the recovery accounts that, let's imagine that these recovery accounts belong to a protocol, okay? So that's probably important to notice. In Damn Vulnerable DeFi, you will learn how to exploit smart contracts, right? And in the way of exploiting them is that you can actually rescue funds from them and deposit them into these recovery accounts. So please, whatever you learn in Damn Vulnerable DeFi, when you go to real life, make sure that you do things right, make sure that you participate in bounty programs and do things the right way, okay? And Damn Vulnerable DeFi is just an educational platform that you should take advantage of to then participate in the ecosystem as a white hat or as a security auditor or security researcher or whatever. Disclaimers made. Perfect. So Truster, again, we will have a lending pool that is offering flash loans. We need to somehow rescue funds from it. Perfect. We have a single contract in this case, which is the Truster lender pool. In the source folder, we usually have the challenges with the contracts, and then we have the test folder. This is just a regular Foundry project, okay? In the test folder, we have this similar folders as the other ones, but we have a Truster folder in which we have the Foundry test. So in the vulnerable DeFi, you have to find vulnerabilities in the contracts and code your solutions for the challenges in the tests. In this case, we have a Foundry test that I will just walk you through it. But all tests in the vulnerable DeFi follow a similar structure. You will have accounts at the beginning, and these are the accounts that you should be using, that the scenario is using. You will only be using the player one, and the challenge makes sure that you only use the player one. But actually, we have deployer and the recovery account. Okay, the deployer is the one that actually deploys contracts, and the recovery account is obviously the one where you have to deposit funds. We said that the tokens in the pool are 1 million tokens, and this is the variable that defines that. And usually, then you will find after the constants the contracts that are involved in the challenge. Okay, in this case, we have only 2 contracts. We have the Damn Vulnerable token and the pool. Perfect. You shouldn't pay attention to this modifier. This is just an internal thing that we use to make sure that you actually use the player account. And then in the vulnerable DeFi, you have the setup. You have the how we test for initial conditions, just to make sure that everything is okay. You should be taking a look at this, but not actually touching this. This is just for you to have context on what the challenge looks like. And then you can actually code your solution here, and then we check off the post conditions where you have actually solved the challenge or not. So on top of having like the context on the README that I showed you earlier, this is actually what you have to do. Okay, so we have to only execute 1 transaction. At the end of the challenge, the pool shouldn't have any balance of tokens. And at the end of the challenge, you shouldn't have any token balance, but the recovery account should have all tokens in balance. So somehow we should write stuff here such that we solved this challenge. Such that moving from these initial conditions, we go to these post conditions. Okay, let's go to the cool stuff. I told you that there is a single contract in this challenge. Remember, this is one of the introductory challenges. As you progress into Damn Vulnerable DeFi, you will find more contracts and more lines of Solidity code and more weird code. In this case, we have something simpler, just because this is 101, and I don't want you to go home all scared and not wanting to come back ever to Solidity smart contracts. So, okay, I won't do line by line, but to some extent, let's see how it goes. We have this lender pool. A lender pool, in this case, will be just a smart contract that has tokens on it. And in this case, is trying to mimic what a DeFi contract would do, that is offering flash loan. If you don't know what a flash loan is, which might be the case, essentially is a way in which contracts can give you money as long as you return that money in the same transaction. Flash loan can be of Ether or tokens, any asset. Should be flash loanable, probably. In this case, it's using tokens. So in this case, the lender pool is actually offering a flash loans of Damn Vulnerable tokens. Those million Damn Vulnerable tokens that we saw on the test are being offered for a flash loan. So to trigger a flash loan, we should be calling this flash loan function that accepts different parameters, right? So the amount that you want to take, who's taking that, and then in flash loans, what we usually do is that you get execution control. So that means that the contract that has the funds will send you funds and will actually execute your code such that you can do something with those funds and then return them. So the usual flow for any flash loan that you will ever see, regardless of more or less complexity, is usually checking the balance before executing a flash loan, which is done in this case, the balance before, transferring the funds, executing the receiver, and then once the receiver is done and executing stuff, checking that the receiver has actually returned the money, okay? And that's done in this case. So 3 steps: check the balance before, transfer the funds, and execute the receiver, and then check that the receiver has actually repaid the flash loan before we end the function. Okay, so we have like, I don't know, 15 lines of Solidity code, and this is badly broken somehow. With very little, you can do very bad stuff on Solidity. So if you want to see this another way, you can actually see this way. I have some little nice diagrams for you today. So in Damn Vulnerable DeFi, usually you will find lots of complexity, not in this case, but in other challenges. So I just want to tell you that usually drawing stuff in diagrams could be useful. So in this case, we have the player. We have to do something in one transaction calling the trusted lender pool such that we can move these million tokens from the trusted lender pool to the recovery address. And then we also have the Damn Vulnerable token, okay? But as we saw earlier, like on the Damn Vulnerable token, there is not much we can do. It's just an ERC20. So we should be doing something on the trusted lender pool. Okay, perfect. So live coding session starts now. You know how these things go. The god of demos should be with us today. So we have a single entry point. Usually, as security researchers, it's good of thinking of entry points. That means, what can I call on this contract, right? You should be able to execute something. In this case, we have a single function. So somehow, we have to execute this single flash loan function on this contract. One good practice that I would suggest you do for Damn Vulnerable DeFi is actually coding your own contracts to solve the challenges. You might be able to, in some challenges, not code your own contracts and just code your solution straight here. That means I will just do some pseudocode, right? But just do flash loan, whatever here. But usually it's a good practice to actually code your own contracts. So let's call it player truster, my contract. I will just be defining this above in a second. Player truster. Let's do this. And you can actually just code your contract here. Okay. Then if we want to just execute stuff, we do this with force test. We use this flag to say force which contract we want to execute. And in this case, we have Druster and Druster.sol. This will obviously fail, but just to get started. OK, perfect. Everything is failing, but we already are deploying an empty contract. Then what we can do is actually define a function to start executing stuff. And we'll do it like the constructor, the tidy way. We don't want to be too messy. So what I'm doing is I'm deploying a contract that I will be using to solve this challenge. But first, I want to set it up, right? So I want to have a reference to the pool, for example, and to the token as well. Then I will show you why this is not strictly necessary, actually, to solve the challenge. But I just want you to take you step by step through it. OK, so we are passing the pool reference to the constructor. So what we should be doing is actually putting that here. OK, and then we have a run function that we will be calling. OK. So probably that should be it for this part. Probably I don't know if then we should be including something, but let's keep it that way. I could pass the token as well in case we need it. In the meantime, if you are following along, you can start seeing what the actual vulnerability is, right? Token. OK, so we have a reference to the demo level token, and we have a reference to Trusted Lender Pool. Perfect. In run, let's try this. We should be able to call the flash loan function somehow, right? And to call the flash loan function, I'm just doing this because I'm thinking, like, that's the only function that I can execute, right? So somehow we should be doing something with this. And if you want to start thinking like an attacker to solve these challenges, you need to understand that you have 4 parameters. So you should be passing something in those parameters such that you can actually take funds out in such a way that then you don't have to return them, right? Because in this case, we have a flash loan function that is actually always checking that we return something. So if you somehow are taking funds out, through this function, you should be able to I mean, not that you should be able, you must return them because code is checking that. So we should find a way to be able to, at some point, take 1 million tokens out of this contract without necessarily returning them. We have a couple of ways to do that, but I want to show you first that how this would work in the right way. So we should be specifying how much tokens we want to take out, who's taking those tokens out, who's the target, and what data we're calling on that target. So if we want to take all tokens, we do this, right? So that's the amount that we want to take. Let's use name parameters because we are fancy and we like to do things the right way. Who's the borrower? Let's say that our contract is taking those funds. Who's the target? Us, because we want to be executing some code after they give us the fund. So this means that at this point, when the contract calls something, it will call us in that target. And then we need to pass some data. And if you're only getting started with Solidity, this will be a little bit harder to understand, so bear with me. We need to specify which function we want the vulnerable contract to call on this contract. So for example, I could have another function here. Let's call it whatever, execute, external. And we won't do mostly anything with it. I will just do a console log. That says, it's very difficult to write. That says hello world, so hello DSS. So in the data, we can specify actually, this is how Solidity works. We can actually specify in this data the function selector that, the function, the encoded function that we want to execute on our contract. So there's a fancy way to do this. If you're not, again, familiar with Solidity, you won't probably understand this, but this is just how we do this. So we specify here execute. Okay, so we are actually taking a flash loan of 1 million DBT tokens, and we are actually saying the contract that they should be executing the execute function. Let's see if this works. I should be passing another parameter. Workshops should have like background music, such as like lo-fi, you know, so we get into the mood. No, oh, sorry, I'm writing whatever. We should pass the token here. Okay. Okay, different error. In this case, it says, can you read it? Yeah, we can read it. It says repay failed. So that means that we are actually taking some funds. The thing is, we are not returning them. How do I know that? We can actually use the beauty of Forge. And in this case, we can see the log, hello DSS, and we can actually see the whole trace, which is probably very difficult to understand if you're only starting out. Sorry, but bear with me. So we are running the run function of our contract that's executing a flash loan. We are getting the transfer. You see here the transfer event, so that means that our contract is receiving that. And then that contract is executing our execute function here. And below that, we are seeing the console log hello DSS. So the usual flow is OK, and we are being able to execute a flash loan and get 1 million tokens. The problem is, as I was telling you, that we are getting the 1 million tokens, but the thing is we want to keep them and then send them to a recovery account, right? We don't want to return them because we know that somehow this is vulnerable. So we should think better of which kind of data we should put into these parameters such that we can actually do what we want to do. The thing is, we have a single function here. We have a flash loan function. And as I was showing you earlier in the diagram, it's not that we have many other options. We only have the Damn Vulnerable token that we could code. That's the other contract on the scenario. It does have other functions that we can actually start exploring and see what we can do with them. Because again, flash loan seems to be just a function on the trusted random pool, but perhaps we cannot do much with it because it seems that from the execution that we see, there's not much to do with it. Also, we couldn't even recall it if we wanted to because it has this non-reentrant modifier. So we are kind of lost. We are receiving 1 million tokens, but there's not much we can do. So let's go to the valuable token that I told you that it's an ERC20. So if it's an ERC20, it has other functions that we can execute on it, right? It has an approve function, it has a transfer function, a transfer from function, it has a permit function, and probably that's it. So perhaps you say, you read transfer and you say, OK, what if I call the transfer function of the then valuable token? These kind of questions of what if are like very, very important for security researchers. Okay, so always think about what if I just call this? As long as you are not testing things on mainnet, thinking of what if and trying things out is OK. So what if I call the transfer function? I don't think it would make much sense because at the end of the day, what we would be doing is kind of replicating this, right? We would be calling the transfer function of the token contract to take funds out. But at this point in which we would be doing that, we would already have the token. So it doesn't make much sense to call transfer. But But, and we are getting to the gist of it, what if I call another function, which is called approve? Suspense. I could do something with that. Because what I would be doing is I would be executing the approve function on the Damn Vulnerable token, but from the vulnerable contract. So I'm forcing the vulnerable contract to execute a function on the token. And that's probably why arbitrary calls, this is what we call an arbitrary call, are very, very dangerous. Because in this way, this function is allowing anyone to specify, and anyone, I mean an attacker, to specify a target and data that this contract will call. In many contexts, that might be okay-ish. I don't know in which ones, but perhaps somebody finds some way of doing that securely. But usually it's not. Because, again, you're allowing, it's like remote execution in Web 2, I don't know. The parallel is hard. But in any case, we can actually execute whatever we want. We can force this contract to execute whatever we want. For example, the approve function. So if you execute the approve function, what we can do is actually force an approval on this contract to whatever address, for example, our address, keep that approval, not moving funds out in the flash loan function, because we don't want to return them. So we will call the flash loan function passing 0 as an amount, but actually triggering the approval. That will make the contract approve our contract. And after the flash loan function is done, we will still have the approval. And that means that we will be able to transfer funds out of the contract because we have been approved. Okay? So that's the gist of the challenge. And we can actually try to solve this now. The target, we said that would be the token. Okay? So the token goes here. Actually, the amount and the borrower in this case, it doesn't even make sense, so we can put whatever stuff we want. Let's just put 0. And data, in this case, we want to call the approve function of the token. So if we go to the signature of the approve function, it has 2 parameters, an address and a UIN 256, which is the amount. So we should specify that here. Approve, an address, and UIN 256. And then, in this case, because the function has parameters, we should pass the parameters here. So we want us to be approved, and we want the contract. We could either do this. How do you write this in Solidity? Like this? Yes. You could do this, or you could do this, like whatever. We are just, in this case, we are getting what we call an infinite approval. Okay. So let's see. In this case, the execute function, we don't need that anymore. So let's see what happens if I just execute this. Okay, nice. We are calling the flash loan function. Sorry, we are calling the run function, which is calling the flash loan function. We are passing some data. Here's the transfer of the tokens, which nothing's happening. This is the event. And then check this out. We are calling the approve function of the Damn Vulnerable token from the vulnerable contract, and we are emitting the approval event. So that means that as a spender, the player truster contract is getting an infinite approval from the vulnerable contract. And the flash loan function is finishing perfectly, and we don't even need to return funds because we are not taking funds out, which is cool. So now that we have an infinite approval, we can do more stuff. For example, we can move the tokens from the pool to a recovery account that I need a reference to. Recovery. Ta-da! Okay, so we pass the challenge. I'm paying the guys in the front so they clap, and then you all clap. So let's see the trace, such that you can actually understand what's going on again. Run function, flash loan function, transfer nothing, call approve, get the infinite approval, and execute then transfer from on the token from the vulnerable pool to a recovery address. And worth probably noticing, us as players never touched the funds. Okay, we moved them from the vulnerable contract to a recovery account that some protocol gave us, and we never touched the funds. Very important. I'm not saying that you will always be able to do that in real life if you're a white hat, but finding ways to do that is good. And there's something else that we can do. We still have time. Okay. There's something else that we can do, because we haven't really solved the challenge, because the challenge says that we should actually be doing things in a single transaction. And because of how Forge works, if I really wanted to solve this challenge right, I think I should use this weird flag, isolate. Let me check. OK. So Forge is telling us that instead of using one transaction, we're using two. And for the challenge, we should be using one. So in this case, when I run the test and using this isolate flag, and that's because how Forge works, it says that we are executing more than one transaction. It says that we are executing actually two transactions. Why? Because we are actually deploying a contract, and deploying a contract is one transaction in real life. And then we are calling a function on that contract, and that's the second transaction that we are executing. So what you can do, and this is true for mostly all challenges in the vulnerable DeFi. If I'm telling you that whenever I tell you that you should be executing things on a single transaction, what you should be doing is executing things from the contract constructor. So we can simplify this little exploit and move everything to a constructor of the contract. In this case, this will mean that we will execute a single transaction. And in real life, for example, that would mean that, I don't know, you couldn't be front run and many other things. Anyway. So it's quite simple. Let me move this to the recovery goes here. And we will just be doing this. And then deleting this. And let's check if this works now. OK. And if I run with isolate, OK, perfect. So yep, that's level 1 thruster. We have some time left, so I will be going over a second challenge that is somewhat similar, but not that much. But it also has a flash loan, so we should be able to solve it a little bit faster, because we already know what a flash loan is. Perfect. So one challenge solved. Let's move to the next one. Damn Vulnerable DeFi, and we will be doing side entrance. OK, if you ever wanted to know a little bit about reentrancy, this contract or this challenge might help you. So side entrance. In this case, it says that we have a surprisingly simple pool that allows anyone to deposit Ether and withdraw it at any point in time. OK, so in this challenge, we are not handling tokens. We are handling Ether. It's somewhat different. We're about to see the difference. So it says that it has 1,000 Ether in balance, and it's offering free flash loans using the deposited Ether to promote the system. We start with 1 Ether. In the earlier case, we didn't have any funds. In this case, we have 1 Ether. Perhaps that's useful, perhaps that's unnecessary. We'll see what happens. And we should pass the challenge rescuing all Ether. Okay, so the pool is vulnerable somehow, and we should rescue all Ether, and again, deposit the funds into a designated recovery account. Let's go here. Side entrance test. Okay. We have this, and the other one that we will be opening is the lender pool. Perfect. Remember, contracts in the source folder, tests for the challenges in the test folder. Shouldn't be that difficult. So, in the test script, as I was telling you earlier, right? So very similar structure. This is just done such that it's easier for you to get into the challenge quickly. We are the players, we have the recovery accounts, we have the deployer, we have the constants that define the amounts that usually players have or pools have and so on. We only have 1 contract in this case, which is the pool, so pretty simple challenge. We have the setup in which the deployer is deploying the lender pool, it's depositing funds, and that's it. And we're checking at the beginning that the pool has enough balance and that we as players have the balance that we should have. And at the end of the challenge, what we should do is actually not have any balance in the pool, and the recovery account should have all balance available. Same as before, we should be coding something on this test to be able to pass this challenge. So let's go to the side entrance lender pool. In this case, I told you we are not using tokens, we are using Ether. So you will see some differences. In this contract, we have a mapping that is actually tracking balances. For each account that deposits stuff, we will have some positive entry on this mapping. Then we have an error, some events, and 3 functions. If you think like a security manager guy, like 3 entry points that you can touch to do something on this contract. A deposit one, withdraw one, and flash loan. The deposit one is essentially just taking some Ether from the caller and tracking that, depositing that into the big pool of Ether that has the contract, and tracking the accounting into the mapping, okay? So you deposit Ether. There's nothing you can do here on top of just depositing Ether and emitting an event. So should be okay. Then we have the withdraw function that is actually reading from the mapping, reading whatever you have deposited earlier here. It's actually taking that here. Then it's cleaning up the mapping, and then it's transferring out the funds that it read using a function. This is like just doing a regular transfer of Ether. But it says it's safe, so it should be safe. So deposit and withdraw. You deposit money, and then the contract tracks that, and then you can call withdraw and withdraw the money. That's it. And then we have the flash loan. That again, it's pretty similar in the structure related to the earlier one that we saw in the previous challenge. In this case, you have the checking the balance, then it's executing something, and then it's repaying it. It's checking that it's been repaid. Note that in this case, we are not using anymore, so the developer seems to have learned the lesson. They are not using anymore an arbitrary code. They are actually calling a specific execute function on the receiver. Okay? So if you want to take a flash loan out of this contract, you should be implementing an execute function on your contract that is able to receive Ether, and then you can do something with that Ether. If we go to the little diagrams that we have, in this case, I don't want to spoil you the surprise. Okay, let's do this like this. You have 3 entry points. You have a player with 1 Ether. You have 3 entry points on the lender pool, and you should be able to move the 1,000 Ether to a recovery account. Okay, so a single contract, we should be executing some stuff on it. So as I told you before, it's good to, let's do this. It's good to have your own contract sometimes. We will pass the pool here. Oh, no, you shouldn't do that. Cool. Function, let's call it run. It's kind of external. Call something on the pool. Perhaps we could call flash long, we could call deposit, we could do something with that. Okay, so let's try this, because we want to execute a flash loan, probably. We should specify the amount. For the amount, we can actually, let's just try taking all funds and see what happens with that. And we should be implementing an execute function that in this case will be the one that the contract will call on us to transfer the funds. Good funds. This should work. Test. Side entrance. Okay. See if I can. Yeah. Okay. In there you can see the logs. Got funds. So that means that yeah, we got the funds from the flash loan. So we are being able to take Ether out of this contract by calling the flash loan function. And then we also have the deposit and the withdraw function. So what I want to highlight in this challenge, before we wrap up, we have some minutes left. So if you take a look at these functions on their own, you will realize something. None of these functions on their own look vulnerable. The deposit function is just where you deposit funds. The withdraw function is where you withdraw funds. It's actually using the checks effects interaction pattern. It's using like recommended libraries. If you take a look at the flash loan function, it seems to be doing things okay. Just checking the balance, transferring funds out, checking that the funds have been repaid. So sometimes when you think about vulnerabilities in smart contracts, and this challenge is pretty much about this, sometimes functions on their own are not vulnerable. The vulnerabilities comes up when you start mixing and putting functions together and making these functions play badly with each other, okay? So I think usually that's kind of a difference between like junior security researchers and more advanced people, is that when you're only starting out, you only look for vulnerabilities in a single line of Solidity code. And sometimes you won't find them that way. Sometimes what you need to do is thinking of ways in which you can actually mix functions and call them twice and 3 times, or call this and then this and then this, like finding your ways into the contract and trying to trigger dynamics that perhaps developers didn't expect. So this challenge is for you to learn about this. Again, if you look at these functions, none of them are vulnerable. But when we start mixing them, we can actually trigger some cool stuff. So what I have now in the test is I'm able to take funds out on the execute function. We have received funds here. So what can we do with those funds? Well, we should be able to repay. We have to repay it somehow. But how would we repay? Well, we need to send the Ether back to the vulnerable contract. But if you take a look at it, and this is kind of a way to make the challenge a little bit easier, it doesn't have a fallback or a receive function. It's not that it has a receive function and blah, blah, blah. So there's a single way in which you can actually repay your funds, and it's actually calling the deposit function. So if I call the deposit function, I took all funds out. So if I call the deposit function now that I have the funds, those funds will be assigned to me as the caller. But the contract will believe that the funds have been repaid because the funds got into the contract. The thing is, they got assigned in a mapping such that then I could call the withdraw function and take those funds out. So let's try that. And that's why it's kind of a re-entrancy thing. Because you take the flash loan, you get the funds, you deposit, you call the contract back, but not on the same function, but actually on deposit. You deposit them, those funds get assigned to you, then you call withdraw, and you take them out. So you are able to bypass the flash loan protections, by recalling on deposit and then taking the funds out via withdraw. So we're actually combining the three functions to execute this attack. Knowing that if you look at them alone, none of them are vulnerable on their own, right? So let's call pool.deposit. I don't think we should be, yeah, okay, perfect. Value, just message the value. So whatever we are receiving, we are depositing it back. And then once the flash loan is done, you can actually call pool.withdraw. I will put a receive function here such that we are able to receive funds. Withdraw, we shouldn't be calling anything. Okay, so let's see what happens now. Okay, so it says that we are just missing putting funds in the recovery account, that I will be doing in a second. Yeah, let's do that now before we finish. And so this. And I should pass the recovery address. Bam. Okay. So we solved another challenge. Woo! If you want to take a closer look at it, again, you can use verbose mode. We can actually see the trace. So we are actually taking the flash loan. It's being the contract, the vulnerable contract is calling our contract. Then we are depositing the funds. Then we are withdrawing the funds. And we are moving those funds into the recovery account. So that's pretty much it for today. It says that I have 2 minutes left, and I will use them to wrap this up. Perfect. So what we have seen is 2 levels of Damn Vulnerable DeFi. This public good that the Red Guild has contributed to the security community in Ethereum. You have many, many more challenges that you can play. We have 18 challenges. I just show you 2. But if you want to take a bigger look at it, you have tokenized vault, flash loans, denial of service, meta transactions, multi-calls, and you can go on and 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 on. So yeah, a lot of things that you can do, okay? Go save them all, go practice Damn Vulnerable DeFi. I think is one of the best resources that you will find ever to learn about smart contract security. You can ask your favorite security researcher in the ecosystem. They have probably played Damn Vulnerable DeFi at some point in the time. Remember, this is word of mouth. This is actually the first workshop we ever do on Damn Vulnerable DeFi. Hopefully it was nice. But it's a thing that has been going around the ecosystem forever, for more than 4 years already. So I think it's one of the best resources that you will find. If you are going to DevCon, the Red Guild is doing a capture the flag and a scavenger hunt. So please sign up. Go to ctf.theredgames.com. The sign up is already there. So if you want to participate on a capture the flag that is not strictly smart contract security related, but it's very much related to Web3, but not on vulnerabilities of smart contracts, you should really sign up to the CTF. And tomorrow, past noon at 1:10 p.m., with Mata, my colleague here from the Red Guild also, we are doing a workshop here on the DSS about hardening dev environments against backdoor attacks. And you will be very paranoid after coming to our workshop, because we will be telling you how attackers can actually try to backdoor repositories in many ways, and how you should be able to defend from that. That's why, for example, I've been using a dev container today. So with 30 seconds left on the clock, I will just say thank you very much. I'm Tincho, I work at the Red Guild, and hopefully you will be learning a lot from the Damn Vulnerable DeFi. That's it.